Chapter 4. Combustion and Flame. Introduction. The last chapter taught you about certain naturally occurring resources that are finite, such as coal, oil, and natural gas. These are all referred to as fossil fuels since they were created from the extinct remains of living things, or fossils. A fuel is a material that, when burned, releases heat or light energy. Fuel can be either solid, liquid, or gaseous. Since the discovery of fire, people have used a variety of fuels for various purposes, including heating food, generating electricity, and powering vehicles. Cow dung, wood, coal, kerosene, charcoal, gasoline, diesel, natural gas, etc. are just a few of the diverse fuels we use for a variety of uses around the house, in business, and to power vehicles. Recall a few of the fuels that are used to power your homes and vehicles. Combustion. Recall the burning of the magnesium ribbon activity you performed in your previous class. It burns brightly white, leaving behind a powdery magnesium oxide ash that, when combined with water, forms a basic magnesium hydroxide solution. As you already know from the last chapter, when coal burns in the air, it releases carbon dioxide and produces heat and light. A chemical interaction between a fuel and airborne oxygen occurs during combustion. Typically, it emits smoke, which is a mixture of gaseous products. During burning, carbon dioxide and water vapor are produced. A chemical interaction between a fuel and airborne oxygen occurs during combustion. Typically, it emits smoke, which is a mixture of gaseous products. During burning, carbon dioxide and water vapor are produced. It is the result of oxygen reacting with a substance, usually one that contains hydrogen and carbon. For example, when methane burns in air, carbon dioxide, water vapor, and heat energy are released. CH4 methane plus 2O2 oxygen is equal to CO2 carbon dioxide plus 2H2O water plus heat. From fuel, from air. Typically, during combustion, liquid or solid fuels, like wood or wax, are heated to a high temperature before producing gaseous fuels that burn non-stop. In other words, combustion is the chemical reaction of a substance, fuel, with oxygen to produce heat. Occasionally, light is also released as a glow or as a flame. Combustible materials are those that burn during combustion. Charcoal and magnesium are hence combustible materials. Conditions necessary for combustion. Why is a person covered with a blanket to put out a fire as soon as their garments catch fire? By eliminating one or more of the prerequisites for combustion, fire can be contained. The following are prerequisites for combustion to occur. 1. Combustible substance. A combustible substance must be present for combustion to occur. It serves as the combustion's food. 2. Support for the process of combustion. As you have learned, combustion is the result of a chemical reaction between oxygen from the air and a fuel, which is a combustible material. As a result, combustion cannot occur in the absence of air or oxygen, which is necessary for combustion. 3. Ignition or kindling temperature. You've probably heard that dry grass can catch fire in certain locations during the sweltering summer heat. It begins on the grass and quickly spreads to the trees, engulfing the entire forest in flames. Such fires are incredibly hard to contain. In the same way, a piece of paper will ignite when it comes into contact with a burning matchstick. However, a matchstick, a piece of wood or coal, does not ignite by itself. We need to use kerosene, oil or paper to ignite a fire in coal or wood. Therefore, the flammable material needs to be heated above a specific temperature in order to begin burning. Its ignition temperature is the lowest point at which a flammable material begins to burn when exposed to air. Until a substance reaches its ignition temperature, it does not catch fire. The temperature at which different compounds ignite varies. You now know why a piece of coal, wood, or matchstick won't spontaneously catch fire in a room. Types of combustion. Spontaneous combustion. Substances with ignition temperature below room temperature start burning on exposure to air. When a substance starts burning on its own on exposure to air, it is called spontaneous combustion. For example, when white phosphorus is exposed to air, it starts burning on its own. Rapid combustion. Rapid combustion is the process of burning that produces both heat and light quickly. The cooking gas in the kitchen ignites and produces heat and light when we place a lit match next to the burner. Examples of fast combustion include the burning of wax in a candle and kerosene oil in a kerosene burner. Explosion. An explosion is a combustion that releases a significant number of gases created during the reaction and produces a great deal of heat, light, and sound. The chemicals in crackers undergo a rapid combustion when they are ignited with a burning matchstick, releasing a lot of gases, heat, and light. The heat released during the reaction heats the gases that are created. The hot gases explode with a loud sound as they expand quickly. Pressing down on the cracker can potentially cause it to explode. Fire extinguisher. Although we can benefit much from fire, unintentional fires can seriously harm both people and property. It is occasionally necessary to put out a fire that has gotten out of control. Two actions can be taken to put out a fire of this kind. 1. Establish a partition between the fuel and the combustion supporter. 2. Reduce the temperature below the fuel's ignition point. Water works well for accomplishing these two goals. Water, however, is limited to extinguishing fires made of wood, paper, or cloth. Water can conduct electricity and inflict shock, hence it cannot be used to put out electrical fires. Because petrol floats on top of water and is lighter than water, water is also not a good way to put out a petroleum fire. Carbon dioxide is a powerful fire extinguishing agent. It covers the fire in a layer and prevents fuel and oxygen from coming into contact. Because it is heavier than oxygen, it does not ascend. These days, carbon dioxide releasing fire extinguishers are widely available. They come in various sizes for both commercial and residential use. Certain compounds in some of these fire extinguishers react to release carbon dioxide. Others have carbon dioxide kept in cylinders at high pressure, Flame. You must have seen a flame very often. Have you wondered how a flame is formed? A flame is formed by burning of a gas. In a candle or kerosene stove, when the fuel is ignited with a matchstick, a small part of it vaporizes and starts. This produces a flame. As the burning releases heat, more fuel gets vaporized and continues to burn. When coal is burned, it initially produces flame as the volatile substances in it burn. After that it just glows as it burns. Observe a candle flame. How is it different from a LPG flame? A candle flame is orange but a LPG flame is blue. What do you think? Is the reason for different colors? In a candle, the fuel is wax. Wax contains big particles that need lot of oxygen to burn completely. The air doesn't have enough oxygen for this purpose. Thus, the wax burns partially and the unburnt particles of carbon in wax keep glowing in the heat. These glowing particles give orange color to the flame. In the LPG, the main constituent is butane, which is a small particle and burns completely in air. As a result, it produces a blue flame. Which one, according to you, will produce more heat? Let us explore the structure of a candle flame. Yellow versus blue flame. Blue or yellow flames indicate proper combustion, which saves fuel and promotes safety. Complete combustion is indicated by a blue flame, so you are not wasting fuel or money. A red or yellow flame could indicate incomplete combustion, which would waste gas and pose a major risk. The amount of oxygen delivered with the gas at the burner impacts the pace of combustion, flame color, and temperature. For flames such as those produced by cooking gas, complete combustion, reduced smoke, and higher temperature are all indicators of a blue flame. A complete combustion of an LPG flame occurs at a temperature of about 1980 degrees Celsius when there is enough oxygen present. An indication of incomplete combustion and carbon monoxide emissions is a yellow flame. Only at about 1000 degrees Celsius does yellow flame begin to burn. The very small soot particles that are created in the flame are what cause the yellow color. The most important warning indication that your gas burner needs maintenance is a yellow flame. As a result, you can be squandering gas and producing harmful carbon monoxide. Light a candle and observe the flame carefully. You will see the area near the end of the wick is dark. This area contains the vapors of the wax and there is no combustion due to lack of oxygen. This is the coolest zone of the flame and is called the dark zone. The outermost zone of the candle is in most contact with the air, so there is maximum combustion here. The flame is blue and it is the hottest zone of the flame. This is called the non-luminous zone. The middle portion of the flame is where wax does not burn completely. So the unburnt particles of carbon glow with orange-yellow color. This zone is called the luminous zone and is moderately hot. If you hold a plate just over the candle flame, you will observe a black deposit. This is called soot and it contains the carbon particles present in the luminous zone. Products of combustion. Most of the fuels used by us contain carbon and hydrogen as the main constituents. When these fuels are burned, They produce lot of energy along with carbon dioxide and water vapor. For example, methane burns in air as follows. CH4 plus 2 O2 arrow CO2 plus 2 H2O plus heat plus light. When the fuel has lot of carbon and the oxygen in the air is not enough to burn it completely, it undergoes incomplete combustion produce carbon monoxide gas. Along with carbon and hydrogen, there are small amounts of other elements like sulfur and nitrogen in fossil fuels. When the fuel is burnt, these elements react with oxygen to form harmful gases that cause air pollution. Characteristics of a good fuel. 1. It should be economical, easily available and easy to store and transport. 2. It should burn easily in air at a moderate rate and produces a large amount of heat. 3. It should have high calorific value. 4. It should have moderate ignition temperature, neither too low nor too high. 5. Upon combustion, it should not produce toxic products. 6. Its combustion should be controllable. 7. It should not leave behind any undesirable residue. Fuel efficiency. All combustible materials may burn to produce heat energy, although not all of them are employed as fuels. When burning, various fuels release varying amounts of thermal energy. The calorific value of the fuel is used to express its efficiency. The term calorific value describes the quantity of heat energy released per unit mass of a combustible substance during combustion. The quantity of heat generated by completely burning 1 kilogram of fuel is hence the definition of a fuel's calorific value. The unit of measurement is kilojoule per kilogram, kg. A higher calorific value indicates superior gasoline quality. Negative effects of fuel combustion. 1. When fuels burn, a variety of chemicals are released, many of which are bad for human health. Even in little amounts, carbon monoxide is extremely toxic. We should never sleep in a tight space with a coal fire that is burning or smoldering for this reason. 2. Soot is created when fuel is burned, and soot makes up a significant portion of the suspended particulate matter, SPM, in the atmosphere. 3. Different oxides of nitrogen and sulfur dioxide, SO2, are also produced by fuels like gasoline and diesel. These can accumulate in the atmosphere and generate acid rain, which is extremely dangerous for all living beings, soil, and historical sites. 4. The dangerous gases create air pollution, which puts city dwellers' health at risk by triggering a number of respiratory conditions like asthma and developmental problems in young children. 5. Excessive carbon dioxide emissions intensify the greenhouse effect, which raises the temperature of our cities and towns even if the gas is not toxic. Global warming is the term used to describe the average rise in global temperature that results from this. Climate change causes extreme weather. Droughts, floods, and heat waves are the main effects of global warming. The world's flora and fauna can be severely devastated by even a slight increase in global temperature. In a nutshell, combustion is a process in which a substance reacts with oxygen to produce heat, light, and sound energy. There are three necessary conditions for combustion to take place. A combustible substance. A supporter of combustion. Ignition temperature of substance. A fuel is a substance that is burned to produce energy. Ignition temperature is the minimum temperature at which a substance starts burning. In spontaneous combustion, a substance starts burning as soon as it comes into contact with air. In rapid combustion, a substance catches fire immediately and burns continuously. In an explosion, a substance burns suddenly in a very short time, producing lot of sound. Along with heat, light and gases. Fire can be extinguished by either bringing a substance below its ignition temperature or blocking its contact with the supporter of combustion. A flame is formed when the vapor of a combustible substance burns. The outermost zone of flame is the hottest and non-luminous. Middle zone of the flame is the luminous zone and contains unburnt carbon particles. The innermost zone is the dark zone and the coolest one. Most of the fuels we use are fossil fuels containing carbon and hydrogen. Burning of these fuels generate gases like carbon dioxide, water vapor and other harmful gases like carbon monoxide, oxides of nitrogen and sulfur. Calorific value of a fuel is defined as the energy released when 1 g of fuel burns completely. In oxygen, a good fuel has high calorific value and low ignition temperature. It is easy to transport and store and causes minimum pollution. It should be cheap. Burning excessive fossil fuels causes environmental hazards like global warming and acid rains.